Welcome and thank you for joining us today for How to Merge the Data Lake and the Data Warehouse, the power of a unified analytics warehouse. My name is Raleigh Gould and I'll be your moderator for today's event. Our featured speakers are John Santaferraro, Research Director at Enterprise Management Associates, and Jeremiah Morrow, Senior Product Marketing Manager at Vertica. John has 23 years of experience in data and analytics, from startups to executive positions at Fortune 50 companies. His deep understanding of the industry comes from years of leadership in implementation, product and marketing organizations, along with multiple big data imagineering efforts. Jeremiah is responsible for marketing initiatives involving Vertica's channel and technology partners. He has worked in sales, marketing, and analyst relations for technology companies, ranging from infrastructure to software, and he is passionate about building a strong and collaborative ecosystem to drive value for customers, partners, and Verticas. And before I hand things over to today's featured speakers, I wanted the audience to know that John and Jeremiah will be concluding today's presentation by taking your questions. Please feel free to log them anytime by using the Q&A functionality. Also, today's event is being recorded, and you will receive a follow-up email from EMA later today with resources from today's event. So I hope that you will check that email out. And now I'd like to go ahead and turn things over to our first featured speaker, John Santaferraro. John?
They certainly are right in the forefront of this merging of the data warehouse and the data lake, and we're going to talk more about that later in the webinar. The agenda for today, we're going to look at what is it that's driving this merge, the changes in the business and data landscape. Why is it that the data lake and the data warehouse are not adequate? What's happening in the marketplace as vendors are attempting to move towards this idea of a unified analytics warehouse? And ultimately, what should that look like? What's the end game for a unified analytics warehouse? We'll give a few tips on deploying a UAW, and then drill down a little bit into cloud and hybrid, and then take a look at Vertica as well. I think you'll find it interesting to see how their technology is very focused on moving people into the future. So to begin, I want to talk a little bit about the changing data landscape, and I think this is fairly obvious to everybody that digital mobile and the Internet of Things have changed the way modern companies operate. And probably most interesting is that when this pandemic hit that we're in the middle of, everybody's digital, mobile, and IoT strategies were put to the test. And those strategies either worked or they didn't. But it definitely has demonstrated with people working from home or working from anywhere and offices sort of shut down and virtual becoming the reality, actually. There's a big shift that is happening in the way that business is done, and it's being demonstrated now more than ever before. So digital, as everybody moved to digital, proved that semi-structured data is just as important as transactional structured data. Mobile, kind of right in that same category. Just all of these mobile interactions are pushing things to a more real-time requirement for engagement with customers. And the Internet of Things is producing massive amounts of machine data and engagement data that we've never seen before. And so there's a major shift that has taken place that really changes the way things look. And so, for example, when we look now at the evolution of the data warehouse, it becomes real obvious that there are a ton of inadequacies in that whole approach. And Jeremiah, I love the slides that you shared with me where you talk about this. I'd love to get your perspective on this evolution of the data warehouse.
Sure, John. So this architecture is familiar to everybody. The data warehouse has served us well for decades and still continues to do what it was built to do very well, and that is BI reporting for transactional data from business systems that were largely housed in a data center. What it did less well, or where it really struggled, was with the explosion of data, and particularly new data types and new sources, the ones that John was referring to on the previous slide, particularly sensor data from the Internet of Things. So a lot of companies turn to the data lake. And so the data lake did a couple of things well. It's a really good place, cheap, efficient mass storage. It could handle the new data types, including streaming data. And it was really good at small exploratory projects by teams of highly skilled data scientists. Where it struggled was replacing the data warehouse and the BI reporting capabilities that the data warehouse brought, particularly query response times and concurrency. And even when we threw a query engine on top of the data lake, it never replaced the data warehouse.
Yeah, and I think it's interesting to note as well when the data lake showed up on the scene. The claims were that the data warehouse was dead, that it wouldn't be needed anymore, that everything would now be done in the data lake, and that really never materialized.
Yeah.
So yeah, there are definitely some inadequacies in the data lake as well. So it didn't do everything that people thought it was going to do when it showed up. Wow, almost 10 years ago now, or more than 10 years ago.
Yep. Yeah, so what you see in production today from companies that have been doing this for a long time are really a cooperative data architecture where the data lake is sitting alongside the data warehouse, and generally you still have your BI and reporting done in the data warehouse, and you have a lot of your machine learning and data science initiatives taking place in the data lake. And there may be some movement of that data lake data into the data warehouse, but largely it's cooperative and not necessarily unified.
Yeah, and so I think what this demonstrates is the need for a unified analytics warehouse. You can't have a complete view of the business and have all of the business insight that you need to be able to operate, especially in real time, with one or the other. So structured transactional data gives you insight to business operations, but it misses so much of things like sentiment and some of the data science work that is done in the data lake, because you can pour so much data in there in a cost-effective manner. And you can't do it all. You can't get all of the insight you need with semi-structured data. And so there is a need for this idea of a unified analytics warehouse. And it's because of the inadequacies of both the data lake and the data warehouse. Neither of them can do both well. And so if you think about the data lake has become the data swamp. It was built initially for semi-structured data. And in order to do data warehouse transactional kinds of analytics, it requires the structuring of the data on read to analyze transaction data, and that happens to be just a huge performance hit. And so the data, in addition, the database component lacks the enterprise capabilities and that are necessary and that have been built into data warehouse technology over the last 20 years. And so the data lake just has a number of shortcomings on its own. It's not able to do both and to do both well. There are also inadequacies of the data warehouse. The data warehouse has become the data jailhouse. So it was built obviously for structured transactional data, And in order to do analysis in a data warehouse, you pretty much have to provide some kind of structure of data on the way in order to be able to analyze it. And the bottom line is just it's too much effort. It takes too much resource. And it doesn't necessarily support real-time ad hoc analysis of the semi-structured data like the data lake does. And so both of the technologies have their inadequacies. And so what's happening is there is a race on for the development of this idea of the unified analytics warehouse. So from the data lake side, and from very early on, actually, the data lake vendors and some of the NoSQL vendors are working to build database technology on top of their file systems, or on top of Spark, or on top of, and they're also working to build SQL query engines to be able to provide, the lingua franca of analytics, SQL, to people who are using the data lake. And quite frankly, this is a huge undertaking to build a database technology and to get it hardened and to provide enterprise capabilities can take 10 to 15 years in the marketplace. And you could look at all of the database technologies over the last 20, 25 years, and you can see that period of hardening and adoption and that point down the road. And so where it becomes enterprise ready. And so this is what's happening from the data lake side of things, because they realize the data warehouse is not dead. They have to provide data warehouse capabilities. On the data warehouse side, the trend has been, and this is that side-by-side concept that you were talking about, Jeremiah. On the data warehouse side, there's a lot of drill-through kinds of capabilities. How do I be able to access semi-structured data somehow through my data warehouse, or with tiered, the tiered storage is another trend in the data warehouse, to be able to have a data warehouse but still somehow store data in the HDFS file system, or to do it in S3 and still be able to pull it up into the analytic compute and be able to run it. And then a number of data warehouse vendors are also building data science tools, so that you can use Jupyter or notebooks on top of the system and be able to do data science kind of workloads. So from the data warehouse side, the vendors are trying to provide access to the data. And so the race for the unified analytics warehouse is on. So I want to take some time to define exactly what is this unified analytics warehouse and what are the requirements for it. And so the idea of a unified analytics warehouse is, first of all, it's unified because it needs to adequately handle multi-structured data in a single platform. So it needs to have access to the structured transactional data and to the digital semi-structured data, to textual data, all in a single platform. So it has to be unified. So side by side no longer works. And then second, it's an analytics warehouse. The days of the data warehouse are gone. I mean, when you think about it, the purpose of a data warehouse is analytics. You have to be able to do analytics on transactional data. The purpose of the data lake is analytics. It's to be able to analyze the data that is poured into a file system or stored somewhere in S3. And so the primary use case for both the data lake and the data warehouse is analytics. So when you bring them together, it is unified analytics. And third, it's a warehouse because the data still, this multi-structured data, both semi-structured and structured data, need to be stored in an organized manner so that they're accessible to both the data scientist and the data analyst or the business analyst. And so the days of the data warehouse are over. The attempts from the data lake vendors to do the data lake house is moving in this direction. the attempt of the data warehouse vendors to handle multi-structured data is moving in this direction, and the end result is this unified analytics warehouse. And so if you drill down into the diagram that you saw on that last slide, first of all, you've got to have unified access, and we'll talk about this in terms of requirement. There needs to be unified operations across these different platforms. Enterprise capabilities are a must because people are running their business on it, and it's operational and real time. There needs to be unified data storage and processing, so it's not just a it has to be more than just a query grid that allows you to run queries across these. There needs to be a unification of the data storage and processing. We'll talk more about this as well. This is what happens, what we're seeing happening as vendors are separating their compute and storage, so it no longer matters where the data is stored. They're able to run these high-performance analytics against them. And then ultimately, there needs to be unified infrastructure too. It's got to work in hybrid and multi-cloud environments. And so we'll drill down into the details of this, but this is what EMA is defining as the future of the unified analytics warehouse. And I want to pause for a minute because I think this is the direction that Vertica is going, and I will ultimately share the EMA perspective on the Vertica offering as well at the end. But Jeremiah, do you want to talk a little bit about how you're moving this direction?
Yeah, sure. So really our approach is, and if you talk to any of our customers, the common thread is going to be a single source of truth. So before we were doing our BI and reporting in the data warehouse, and we were doing our machine learning and data science in the data lake, and here you're sort of smushing those two together. And through subclustering and workload isolation, we can work off of an S3 bucket or an HDFS storage solution and do our BI and reporting alongside our data science and ML, and allow departments to do their own analytics, all working off of one single source of truth for the organization.
Awesome. Thanks, Jeremiah. And like I said, I'll talk more about this at the end because EMA has done a fairly in-depth analysis of how Vertica is delivering the unified analytics warehouse. So first of all, data requirements. In order to be a unified analytics warehouse, there needs to be native support for all of the different data types. So structured transactional data coming from operational and business operation systems. There needs to be native support for complex data types. Some of the digital data like JSON files and XML. There needs to be support for textual data because textual analysis is becoming extremely important, especially with the need for real-time engagement with customers, employees, partners, prospects, all of those things. And then there needs to be native support as well for streaming data because real-time within digital engagement models is no longer a niche capability. It is a mainstream capability that is needed by every single digital business. Or by those bricks and mortars businesses that are attempting to become digital. So data requirements need to cover all of this multi-structured data, all of these multi-structured data types. Second, the unified analytics warehouse needs to have enterprise capability. It needs to be enterprise ready. And so from the administration side, there ideally is one set of management and orchestration capabilities. Security is important from the moment that a digital transaction is created as it streams into a unified analytics warehouse, as it is analyzed while it's in motion as it is finally landed either in a database or in a file system or directly into S3. I mean, there needs to be security and privacy in place for the entire journey of that piece of data. Performance is absolutely an enterprise requirement because and it's not just performance of one type of analysis, it's performance for all types of analysis. Scalability because the amounts of data are growing. Agility to change because data drift is a massive issue today, and changes are happening in source, analytics, and target. And then as changes are happening back as the data is analytic insight and intelligence is fed back into that operational system, change happens in all of those places now. So agility is incredibly important, resiliency. And then on the other enterprise capability from my perspective is that the most modern unified analytics warehouse technologies are going to be AI enabled. They're going to be autonomous. And AI enablement comes in two areas. One, recommendation, so that as data is coming into that unified analytics warehouse environment, there's recommendations on structure, schema, data, relationships, tuning. But recommendations are only half of AI enablement. There needs to be automation. And you can see a list here. There's just a number of areas where the most advanced developers of unified analytics warehouse technology are already automating a number of the things that used to be done manually by a database administrator or a data lake administrator. So the unified analytics warehouse needs to be enterprise ready. There's also infrastructure requirements for the unified analytics warehouse. And it needs to be able to cross all of these different types and tiers of storage, the analytic platform, the distributed file systems, object storage. The fact remains that there's massive amounts of data being collected, and historically the analytic platform has been expensive, and therefore people move stuff into distributed file systems to be able to store it at lesser cost and be able to collect more data, not knowing which data was going to be useful to them in the future. And they obviously discovered that there's a lot of this digital data that's extremely important, but they can't, it's not affordable to structure it and put it into an analytic platform. And then that became expensive, and so data is being moved into a third tier of even less expensive storage, into object storage. And the idea of the unified analytics warehouse is that it shouldn't matter where you store data. You should be able to easily run analytics and high performance analytics on data of different types that is stored in any of these types of infrastructure. There's also cloud requirements for the unified analytics warehouse. EMA did some research at the end of 2019 that showed that approximately 53% of all data is now stored in the cloud. And so what that means is that the ability to run your analytics program in hybrid environments where part of the data is on premises and part of the data is in the cloud is critical. It's necessary. Nobody has, almost nobody has all of their data on premises or all of their data in the cloud. It's a hybrid environment. And then there's the issue of multi-cloud as well, where that data is not just being stored in one cloud, but in multiple cloud instances or multiple cloud providers. And so the requirements for the unified analytics warehouse ideally is to have one single pane of glass to be able to manage your analytics warehouse, your unified analytics warehouse across on-premises and multi-cloud environments. Additionally, there should be simple migration. If you're running a test program in the cloud and want to move it on premises, or vice versa, you're running a test in the lab and want to move it into the cloud, or move from one cloud provider to another. It should be simple to migrate. And that's why we're seeing the separation of compute from storage, because it shouldn't matter what lies underneath. And then there should be a common foundation. You should be able to run your unified analytics warehouse on any of these environments, and it should basically live and act the same. And that's where we're moving. And you're even seeing EMA's even seeing some of the cloud vendors now trying to figure out, well, how do we take our cloud technology and make it available to people to run on premises? So there's requirements for the cloud around the unified analytics warehouse. There's also the analytics requirements for the unified analytics warehouse, and here in two particular categories. One, analytics historically on the data warehouse side have been embedded into the analytic platform, into the processing engine, where at the core of that processing engine, they can run at super high performance speeds. And these are pre-built analytics. And the idea is that needs to be accessible to all of the data now. And so there needs to be a common set of analytic algorithms that run across these different storage and data types. And there needs to be a high performance capability. You can't be running, real-time kinds of analytics on a data lake and pulling it from the data lake up into a Parquet columnar database that sits on HDFS that doesn't perform. That doesn't work anymore. And they need to be embedded and pre-built so that they can be rapidly deployed as well as changed and morphed as business requirement changed. And so the second part requirement for the unified analytics warehouse is that it needs to be highly performant for different types of analytical workloads. Whether they're data intensive or compute intensive or high intensity, where there's a lot of data and a lot of complexity, if there's a high concurrency of queries being run against it, the unified analytics warehouse has to fit that analytic performance model. And then finally, the unified analytics warehouse needs to provide unified access, so that it supports a number of different use cases and a number of different users. And for the past 10 years, we've been in a religious battle, right? There's the data scientists who say, well, I want my data in the data lake where I can do whatever I want and create my own structure as I need it, and I want all of the data in there. And the data analyst who is crying, no, SQL is the lingua franca of analytics, and I have to have SQL access. Well, the idea of the unified analytics warehouse is that you basically have one platform for all of these use cases, for SQL access, for the business analyst and data analyst, for the data scientist to be able to run R and Python, for machine learning types of algorithms, where that single platform actually supports all of the work from of what you would typically see in ML ops. It needs to support notebooks and basic kinds of BI reporting and dashboards. It has to be all of the above, because guess what? Users expect a platform that allows them to do all of this. And normally, what happens in organizations is because the old world was different platforms for these different kinds of access to analytics, it required basically the data scientists doing their work and somehow passing it on through through a model to another SQL platform before it goes into production. And it was clunky. And so the idea of a unified analytics warehouse will actually not only cut costs, but it will speed this whole process of getting analytics from the lab into production. So I want to talk also just some ideas about what does it look like to deploy a unified analytics warehouse where the data lake and the data warehouse are finally merged. And so there's a number of vendors that are now moving this direction to towards the unified analytics warehouse. Would highly recommend, if you're talking to a vendor and they don't have a vision for the unification of the data lake and the data warehouse, go the other way, because these can't continue to live separately. Second, choose a platform that is well into their transformation into a unified analytics warehouse vendor. And then look for a high-value project with a mix of data and use cases. So the only way to test out a unified analytics warehouse vendor and platform is to have, you know, a place where you're going to get value out of the project and where there is that mix of data in the analytics use cases that you're trying. Customer-facing examples are a great place to start, where you might, for example, have a set of customers that you're engaging both on the internet and in mobile, where there is either a marketing engagement or a sales engagement, or you're delivering a service digitally in that area. And so you're going to be collecting real-time data, and the format of that data is typically going to be, you know, a JSON file or something like that that you would normally put into your data lake. And then on the back end, you have all of your historical data for customers like them, your customer profiling, your prospect profiling. You have all of that data in a transactional system. Or you've got a digital interaction or a digital service you're delivering, and there's high potential for fraud, and you need access to the PhD insight that sits in your massive data warehouse that tells you what fraud looks like. So pick a project with a combination of the third and fourth points there: high value, mix of data and use cases to really test this out. And then you can begin to test out the capabilities in that hybrid environment. Find out, does it work? Can I actually run my data science workloads, and can I run my SQL workloads, and can I combine those to move things quickly into not just a test environment, but into a production environment? And then you got to plan for end of life of your data warehouse and data lake technologies. If you have in place old data warehouse or data lake technologies, and there's not a vision for bringing that technology into that combined data warehouse, data lake mode, then plan for end of life on that, and continue to migrate more and more of your projects into the unified analytics warehouse. I want to say a little bit more as well about unified analytics warehouse for cloud and hybrid environments. I think here it becomes, whether you're looking at hybrid or multi-cloud, a common management system is super important. Not managing these systems as separate pieces, parts. Common infrastructure. One of the things that is really interesting to me is that we're beginning, you know, obviously there's been a massive move to the cloud, but we're beginning to see people moving from the cloud back to on-premises because of technologies like Kubernetes. I mean, the private cloud in a company's own data center is becoming as effective or more cost-effective than some of the cloud offerings. Why? Because if you think about it, the cloud vendors, they don't have any incentive to produce high-performing software so that it doesn't take up more hardware, because they make money on both. And so they're just trying to deliver highly performant services, no matter what the cost is. And so there's common management that is important, common infrastructure, and then the most important, I think, is interoperability between the multi-cloud instances and in the hybrid instances where some of the data is still still included on premises. And that includes interoperability of the data. Can I move my data freely among those platforms? Can I run queries across those platforms? And is it easy to migrate and move data? Because this year I may think that cloud is the way to go. If cloud gets more expensive next year for some reason, I want to move it back on premises, there shouldn't be an issue of the way that your software runs in the cloud and the way it runs on premises. So again, be looking for that interoperability in those different environments. I'm gonna go ahead and turn it over to you, Jeremiah. It's been fun to have conversations about how you guys are already moving in this direction. So why don't you go ahead and take it from here and share with the audience what you guys are doing around the Unified Analytics Warehouse.
Sure, thanks, John. And I definitely want to talk about how our customers are doing this in production today, but really quickly, I want to give a quick overview on Vertica for everybody here. So what is Vertica? At our core, we're a SQL database. We are a blazing fast SQL query engine, and then we have built-in in-database advanced analytics like time series and geospatial, as well as SQL-based machine learning. We're a software-only solution, so we can be deployed on premises, on commodity hardware, in any of the clouds, or directly on a Hadoop node for SQL on Hadoop. Generally, when we talk to customers, the challenges that they're facing regarding their data are related to scale. Scale in terms of data volumes and scale in terms of concurrent users. So Vertica was really architected from the ground up to remove those capacity constraints. We're a column-oriented MPP database with compression algorithms to reduce the amount of storage required for your data. And so this allows us to read massive data volumes and perform analytics on average 50 times faster than many of the legacy providers. Just to put 50 times in perspective for you, if you had a query that took 8 hours, so maybe you ran it overnight or it took an entire business day, Vertica could return results on that in under 10 minutes, and usually at a lower total cost of ownership. We're also very good against the cloud players. So this is hot off the presses. This benchmark was run with McKnight Consulting Group over the summer, featuring Vertica in Eon mode, which is our separation of compute and storage, our cloud optimized architecture, Amazon Redshift, and then an unnamed cloud data platform. You would all be familiar with them if they had chosen to be named, but probably because of that graph on the right. They chose to remain anonymous for this. So we consistently beat both of the other tools in queries per hour and also the shortest time for the longest query thread. But where we really come in strong is over there on the right, where we produce these results on average 1.8 times less expensive than Redshift, and something like 6 times less expensive than unnamed cloud data platform. So that's a high level on who Vertica is. Now I'm going to talk about how we are doing unified analytics today with one of my favorite customers, Philips Healthcare. So you're probably all familiar with Philips. They produce medical devices like MRIs, scanners, really anything across the health spectrum. And they wanted to build a predictive maintenance tool. This is what John was talking about with one of those high-value projects. So they wanted to eliminate unplanned downtime for their customers. And so if you think about maintenance, in a reactive maintenance cycle, the clock doesn't start on getting that device up and running until a customer calls in and reports a problem. In a predictive maintenance cycle, instead, you're looking for trends and indications through the data that a device is going to fail, and responding to it earlier, scheduling the service, and hopefully avoiding the problem and the downtime altogether. So this was a pretty, it was a big data challenge. They had millions of data points that are produced every day from these machines and landing in a data lake. They're bringing that data into Vertica, and they're combining it with a lot of legacy data, 3 to 7 years of historical data. And if you think about things like sales records from their CRM, service reports, diagnostic tests from years of doing this kind of maintenance, all of that is coming together and powering dashboards that are monitoring these devices 24/7. So what are the outcomes? First of all, massive volumes of data, 500 terabytes, 30 trillion data points are going into this solution. They're integrating 80 different data sources, again, the data lake, the sensor data, along with legacy databases and business systems in their data center. These feeds are running 24/7, logging millions of reports every week. All that said, it only took them 8 months from scratch to put this solution into production, and they're marching towards 0 unplanned downtime. What really gets me about this use case and why I love it so much are the customer testimonials on the right. They are often showing up and repairing these MRI machines before their customers realize that there's an issue. They are able to ultimately see more patients, provide a better level of service, and improve patient outcomes for their end users. So now I'm going to hand it back over to John to talk a little bit about their analysis of Vertica and how we meet the demand for the Unified Analytics Warehouse.
So EMA did an in-depth analysis of the Vertica 10, which was introduced recently. And in that analysis, you can see the results here in terms of the different requirements for a unified analytics warehouse. And I want to start with the data requirements, because for a traditional data warehouse platform coming from that world, the most challenging thing is to be able to analyze multi-structured data. And what Vertica did, they did a couple of things. One, they separated compute from storage. So their engine an analytics engine is not required to only use that high-performant, highly optimized analysis on data that is in their database. So with Vertica 10, they are able to handle semi-structured data types, maps, arrays, structs, the kinds of things that are typically stored in Parquet and HDFS. And instead of replicating the data in Vertica to run a query and having to bring it into the database, they can access the data directly in HDFS or S3 object storage. And so it eliminates that need for data storage duplication. And it means quicker answers to questions in multi-structured data. And there's some really cool things that they did. They, because it's fortunate for Vertica, the company contributed heavily to the Apache Parquet open source project when it first began. They built the C++ versions for Parquet and Orc. And their contributions to that open source project are what give them the ability to do a couple of things. One, they can actually write out to Parquet, which is a function that is normally only done by data lake vendors. And so you can see how they're moving into this world of the unified analytic warehouse. The other cool thing is that they don't have to explode a JSON file, for example, or parse a JSON file in order to be able to run analytics. And a lot of data warehouse vendors need to do that. Okay, it's got to be, well, it's a JSON file. We got to parse it. We got to pull it into the database. And so Vertica has really scored high on that data area, and that's the hardest. That is the biggest challenge for a traditional data warehouse vendor. In terms of enterprise readiness, enterprise readiness has been a part of Vertica's history for years. There's no question, and there was no question when we began to dig into all of the enterprise requirements that they meet those requirements. And that, by the way, is the biggest challenge for the data lake vendors. And so, that one was scored highly. In terms of infrastructure, I've already mentioned this. They completely separated the compute from the storage, so that the customer can store data on any type of infrastructure, whether it's a Apache Hadoop or in Spark or a hybrid model or an S3. It doesn't matter. And then in terms of multi-cloud and hybrid requirements, because Vertica is a software vendor, they only have one software version no matter where you run it. So they scored fairly high there. In terms of analytic requirements, basically analytics are in their core, high performance analytics, different use case analytics, and because of what I mentioned in terms of their data requirements in Vertica 10, they're also able to handle data science kinds of use cases, and that ultimately gives them the broad user support. So we think that at this point in the race for the Unified Analytics Warehouse, Vertica is definitely one of the leaders. And I'll mention as well that here at EMA, we will be doing a radar report at the end of the year to evaluate a broader set of companies that are moving into this space. So stay tuned. More coming from EMA on this concept of the Unified Analytics Warehouse.
Thanks, John. And I would also, from a hybrid standpoint, I think this is something we're really proud of as a software-only vendor. So our stance is the world is certainly multi-cloud. It's certainly going to be hybrid cloud. We have a lot of customers who tell us even if they wanted to move all of their data to the cloud, it's expensive, it's difficult, and not always necessary. And so our goal really as a vendor is infrastructure decisions that you make today should not impact your ability to do something different tomorrow. And we also offer that separation of compute and storage on premises with one of our partners, Pure Storage, which is also a pretty cool feature.
Awesome. So let's go ahead and move on to the Q&A. Sure. You can log your questions in the Q&A panel, and Jeremiah, do you want to talk about some of the links that are here for folks to get more information?
Yeah, sure. Really quickly, if you're interested in learning more, we'll make sure you get all of these links after in the PDF. But you can access EMA's the race for a unified analytics warehouse at vertica.com at that link. That McKnight Consulting Group Cloud Database Performance Benchmark is also available at vertica.com. We have an incredibly active blog, both technical blogs and business writers. We publish a lot. And then follow us on LinkedIn so you can get all the latest. And then down there at the bottom, we have a Vertica Community Edition if you want to try it out. That's 1 terabyte and 3 nodes for free for as long as you want to use it.
Great. Thanks, Jeremiah. As Jeremiah noted, I will be sending out these resources. As attendees, you will receive a PDF of today's speaker slides and some additional resources. I'm going to go ahead and jump into the questions, starting with you, Jeremiah. How does a unified analytics warehouse in general, and Vertica specifically, enable, support advanced analytics like machine learning?
Sure. And I think we mentioned it above, but machine learning and advanced analytics really drove a need to unify the data. If you think back to that slide that I shared with Philips, they might have been able to build a decent model out of their machine data, but being able to bring all of the data together and train a model on what is ultimately a holistic view of what's going on with these machines, that is really, I think, going to be the main driver for the UAW. From a Vertica standpoint, we're laser focused on removing the biggest barriers to machine learning for enterprise organizations, and that is time to production, the incredible amount of cost and complexity with building a model when you're pulling data out, working on a subset, training the model on that subset, and then putting it back into the database. So we have in-database machine learning and advanced analytics functions. They're in SQL. So we actually have a lot of customers who have very little data science talent. Getting started with SQL-based machine learning algorithms and training it on the entirety of the data set, which ultimately produces an accurate model and eliminates a lot of the challenges with moving data out and back in.
Thanks, Jeremiah. John, I'm going to jump over you now. We currently have 4 different platforms we use for analytics. Are you suggesting that we may be able to consolidate them on a single platform?
Absolutely. I think that is the direction that things are going. So the EMA did some research last year that showed that the average company has between 4 and 8 different platforms to run their entire analytics programs, and so there's a ton of inefficiency there. So I believe that especially with the hit of the pandemic, there is a shift of concern around not just revenue generation, but now cost-cutting measures. Cost-cutting measures went from not as important to highly important in this new environment. So I think that right now we are going to see a shift towards consolidation again. Consolidation sounds like an old word because for the last decade people have been adding new platforms because there were so many new capabilities and they were enabling revenue generation in different types of ways, or cost-cutting measures that made them cost-effective and showed return on investment. Well, I think that we're going to see a major shift now, and the shift is going to go back toward consolidation. So people are going to be looking for the unified analytics warehouse as a means of consolidating the 4 or 5 or 8 platforms that companies have today to run their analytics programs.
Great, thank you, John. Another question that came in for you is, Vertica is not a cloud vendor. How can they compete with companies like Amazon and Microsoft?
Okay, well, and you might want to talk about this as well, Jeremiah, but I mentioned this, but I want to reiterate it, that there's a sense in which EMA is beginning to see people move away from cloud vendors. People move to the cloud because they thought it would be less expensive, and they're finding out that it's so easy that they end up with more people using and more people buying and not using. So there's utilization issues, and they end up spending more on their with their cloud vendors than they were originally managing everything themselves on premises. And so, and in addition to that, as I mentioned, the cloud vendors are not incented to make high-performance software that lessens the need for hardware, because they sell both, and they sell both in a package. And as a consumer, you never know what that mix looks like or what the performance looks like. And so I think there is some potential to move towards the software-only vendors who build highly performant software to lessen the need for infrastructure and to be able to run that either in the cloud on existing infrastructure in the cloud and use the cloud vendor just for their infrastructure, or to be able to bring some of that back on premises. I think we're seeing an adjustment of the of the massive let's everybody run to the cloud because it's cheaper mentality. I think that wave is coming to an end.
Yeah, I would agree. I would agree with everything that you said, John. And I think it comes down to if you look back at that McKnight benchmark that I shared, it really comes down to us giving users control over their data. One form that takes is if you have a query that's running poorly, you can optimize it. We give you the ability to tune that query, whereas a lot of the cloud providers just want you to throw more compute at the problem, which adds up very quickly. And then the other thing is control over infrastructure decisions that you want to make in the future. We're not a black box. We're incredibly open, which allows you to make that decision to move on-prem or just not move data to the cloud at all if that's what you want.
Thank you both for those insights. Jeremiah, let's take one more question. Besides Philips, where are you seeing the most demands for a UAW, and what kinds of problems are they solving?
Sure. So we see a lot of demand in, I think, two areas. One is companies that are pursuing advanced analytics and machine learning, as I mentioned earlier. That's a huge use case for us. And then the other one is companies with a lot of IoT data, sensor data that they want to contextualize with data from their internal systems. And a couple other examples outside of the healthcare space, because I think this is really applicable to across industries and across business models. But a couple of our customers that are doing it really well, Anritsu is in the telecom space, and they are providing applications for telecommunications providers to monitor their network, and Vertica is embedded in that. And then Uber is probably one of our most well-known customers, and they're using advanced analytics like geospatial and machine learning in order to match riders with drivers and also increase surge pricing basically with demand. So sorry about surge pricing. That is Vertica's fault, but it is a function of the unified analytics warehouse.
Thank you, Jeremiah and John, for taking those questions, and I wanted to thank our audience for joining us today. As I mentioned, you will be receiving a follow-up email today that will include an on-demand playback, a PDF of the speaker slides, and all these great resources from Vertica. So I hope you'll check that email out. And I hope that we'll see you at a future EMA Research webinar. Thanks again for joining us, and enjoy the rest of your day.